Hello, this is Anushya, your host for today. Welcome everyone to a joint webinar on the role of GMSL2 cameras in autonomous systems and how it enables functional safety. We are excited to have you here. Today's session features experts from Econ Systems and Analog Devices who will discuss how GMSL2 cameras enhance safety and efficiency in autonomous systems. Please note that we'll have a live Q&A session at the end. You can submit your questions in the Q&A box at any time. Let's begin by introducing our speakers. First, we have Tom Brady, Principal Applications Engineer at Analog Devices. He is currently leading their initiative to extend GMSL technology for multimedia applications. Tom has over a decade of experience working with GMSL and SerDes technologies for automotive applications. Next, we have Dilip Kumar, Product Manager of the Industrial Business Unit at Econ Systems. He has over a decade of experience in the embedded camera industry. Dilip has worked with 100 plus clients to integrate Econ Systems cameras into their systems. Over to you, Tom.
Thank you, Anusha. Hello, everyone. And first, we're going to start off with a very basic overview of the GMSL technology. So GMSL is a highly configurable SerDes interconnect solution that allows you to have simultaneous transmission of real-time high bandwidth data, control, and power all over a single wire. The two main use cases that we see for GMSL are from a camera or sensor back to a processor, and from a processor out to a display. This technology is not new. It has been widely adopted by the automotive industry, but now, as part of ADI's initiative, we're leveraging this technology into other multi-market applications, such as industrial automation with cobots, AMRs, AGVs, agricultural field equipment, intelligent infrastructure, digital healthcare with surgical robotics and endoscopes, aerospace and defense, and commercial in-flight infotainment. And we know that all of these industries can greatly benefit from implementing GMSL in their systems. So as I mentioned, GMSL is not new by any means. It is over 20 years of innovation in the automotive industry, and we're currently onto our third generation of GMSL products. Over 900 million ICs are on the road, with the majority of automotive OEMs using them in all of their cars. Some of the key benefits of GMSL is being able to simultaneously transport data, control, and power all over a single wire, really helping to reduce and simplify your cabling infrastructure. Cables, which translate to weight, reducing them can allow for better fuel and battery efficiency, reduce your points of failure, optimize board space, and reduce the cost of expensive cabling and connectors. GMSL supports a variety of topologies, such as sensor fusion and the ability to synchronize multiple different cameras all together back into a processor, aggregation of data into a single port, replication for redundancy or duplication efforts in functional safety applications, and a variety of other video management devices. So GMSL, as I mentioned, we're on our third generation, but today, which is currently available on analog.com, is the GMSL2 technology, which operates up to 6 gigabits, which enables 8 megapixel cameras at 30 frames a second. And GMSL3 doubles that bandwidth all the way up to 12 gigabits for even higher resolution cameras. But one of the things is by familiarizing yourself with GMSL2, it allows for an easy upgrade path to GMSL3, because they're backwards compatible, a previous generation, and they're also pin-for-pin compatible, allowing for 3, 6, or 12 gigabit speed options. One of the other key benefits of GMSL is the safety and security that it brings to the overall video link. We have deterministic microsecond latency and extremely low bit error. And on top of that, we have our adaptive equalization for some more analog robustness, our link diagnostics and data integrity checks, all of this while meeting the most strict automotive EMI and EMC requirements. And on top of everything else, these devices are rated for ASIL-B functional safety, and we provide all the material that comes along with it. So there's a lot of key features of GMSL which really can help with simplifying systems and complexities, but I wanted to focus on 3 of the key ones that relates to the topic of this webinar, those being the adaptive equalization, our sensitive data tunneling, and the robust data integrity. On top of this, we have other features such as reference clock, power over coax, and full duplex communication, but I'd really like to focus on these with a little more detail. So our adaptive equalization is part of the analog robustness of GMSL2, and it's a differentiated feature. The adaptive equalization, or AEQ, benefits from over a decade of design experience with equalization techniques. The GMSL AEQ is a patented technology which maintains optimal coefficients over the lifetime of the design. And AEQ is a real-time feature that ensures GMSL link quality over changing harsh conditions such as temperature change, cables aging, cables bending, and it's able to equalize and optimize the channel between these two chips. This feature initializes itself on any channel length without any configuration and is completely automated in the silicon. And all of this happens while continuously monitoring the signal integrity at a once a second rate. To show where this is and how this happens, below is a diagram of where the equalization occurs. Right after the signal is received, it's equalized, and the coefficients are updated depending on what is happening on the link. And to demonstrate this, here's an example in the top right of the adaptive equalization happening. All of this data can be easily obtained via I2C or conveniently taken from the GMSL GUI. The equalizer coefficients on the top left and the eye diagram on the top right of the GMSL signal were taken at a room temperature. Beneath that picture, you'll see a set of coefficients with the previous settings in black and the new updated ones in gray after I let the cable soak and get hot for about 15 minutes. The changes of the coefficients are minor, but what you'll see is the eye diagram itself is nearly indistinguishable between these two conditions. And that's the beauty of GMSL, to maintain optimal eye diagram and signal integrity under all conditions you can throw at it. To build on to the robustness of GMSL, some of the digital robustness comes from the sensor data tunneling capabilities. So GMSL devices have two modes of operation, pixel mode and tunnel mode. Pixel mode is from the earlier generation of GMSL2 chips that allowed for flexibility to bridge video interfaces to another video interface. This was done by the serializer looking at the video packet, decoding it into an arbitrary pixel stream, and sending this across the cable. The data is then recombined into the video interface required by the processor. This allowed for flexibility, however, it did require the GMSL devices to interact with the data. And this was really not seen as ideal by some automotive OEMs from a functional safety perspective, because even though the data should be identical, there was the extra variable of the GMSL devices deconstructing and reconstructing the data. So due to this concern, we implemented tunnel mode. Tunnel mode allows for optimal functional safety, which is one of the main requirements for these devices, whose algorithms are making critical decisions based on this data. Tunnel mode is intended for applications where you're going from a MIPI output interface on a sensor to a MIPI input interface on a processor. And in this mode of operation, there's really no requirement for these GMSL devices to touch or reconfigure the data. So GMSL simply provides a tunnel for the data to travel directly through. Tunnel mode takes all the data coming out of the sensor, including the header, the footer, the CRC, and simply puts it into a GMSL packet to ship across the link. And in this way, we can ensure that the data was transmitted correctly across the link. So when the deserializer outputs raw data, it's the exact pixel-perfect data coming out of the image sensor. So for example, if the processor was seeing a bad CRC from the data coming out of our deserializer, but the deserializer and the serializer weren't reporting any issues, it allows the processor to know right away there may be something wrong with the imager and address the issue that much faster. And another key system benefit of GMSL is the comprehensive list of error monitoring and diagnostics. On the right is an example of the numerous errors that can be monitored, and the GMSL GUI provides a way to visually see all these errors and the error statuses, but all of this can be read back simply via I2C. GMSL also has a dedicated error pin to indicate when any of these monitored errors has occurred and react quickly as possible. These GMSL devices were designed with functional safety in mind from the definition phase, and all the devices are ASIL B rated, which is approximately equivalent to around a SIL level 2 rating. They have a power on self test that provides a pass fail criteria, a logic built in self test that verifies the logic blocks are correctly functioning and free of latent faults, a memory built in self test to check the memories for defects on power up, and a register CRC to make sure that there's no unintended changes to the configuration registers. There's also CRC checks on both the forward channel video and reverse channel communication. And we have automatic retransmission on that reverse channel to ensure the transmitted control channel data is received. And if not, we can retransmit it if no acknowledge is sent. Lastly, all the GMSL3 devices and a few of the newer GMSL2 devices support forward error correction, or FEC. And FEC takes a slight bandwidth hit of about 6.7% on the GMSL link, but it exchanges it for significantly improving the bit error rate of the video transmission to essentially 1 bit error in the lifetime of the design. And with that, I'll hand it over to Dilip to talk more about how the functional safety features of GMSL helps different application use cases. Over to you, Dilip.
Looks like I was on mute. Can you guys hear me now? Okay,
Yes.
perfect. All right. Thank you, Tom, for the brief introduction about GMSL and its features that focus on functional safety. As already explained, GMSL has a lot of inbuilt mechanism for maintaining signal integrity and reading back diagnostic information from the device to the host. Using the status information, the probability of risk of failure in the system can be calculated. This is a fundamental requirement for functional safety. There are industry standards for functional safety depending on the use case. For example, machinery that is operated in an industrial setting, such as a robotic arm or autonomous mobile robots, are classified under different SIL grades depending on their risk category. Similarly, the automotive industry follows the ASIL grades for risk classification. Functional safety certification is applicable for subsystems which include not just the camera but also the host. As you see in this image, a standard system takes in just the camera video data, whereas a functional safety rated system reads in the diagnostic data from the camera to perform real time risk assessment and perform corrective actions. There is usually a dedicated controller that takes care of the safety aspects of the system. This helps ensure overall safe operations at the edge by reducing the risk. There are many applications that benefit from the usage of this type of implementation. The most critical one is in an automotive vehicle. Today's car use so many different sensors to provide ADAS capabilities, and an error in the system can prove to be fatal for passengers as well as pedestrians. Similarly, collaborative robots such as AMRs and AGVs are used across the industry for various tasks, and there is usually a human involved in the workflow. Because of their proximity with humans, it is important to ensure the safe operation of these robots. Surveillance and traffic monitoring systems may not possess a threat to humans since they are stationary, but the diagnostic information from GMSL cameras are vital to plan critical maintenance activities before system failure. This is helpful because these cameras are usually not easily accessible and requires proper planning for maintenance. Healthcare and aerospace industries are growing markets where we see the benefits of GMSL being leveraged. Let's see more in detail about some of these applications. Many of the ADAS features in modern vehicles, such as lane keep assist, blind spot monitoring, collision avoidance, rear view camera, and so on, are enabled by cameras with different optics and resolutions requirements. Some use cases, such as driver monitoring and occupant monitoring, requires cameras with monochrome or RGB-IR imaging capability. While the optical and image sensor requirements for these cameras may vary, it is important to ensure these cameras are functional whenever these features are enabled so that the driver can make real time decisions without injury to others on the road. Cameras are mainly used in off road vehicles such as trucks or an excavator to provide surround view of the large equipment for the operator sitting in the front. These cameras need to be able to withstand harsh environment such as dirt, snow, ice, and a lot of mechanical shock and vibration as well. The FACRA connectors used in GMSL cameras help ensure a reliable connection to the system. Agricultural equipment such as tractors also use cameras to monitor the health of crop in the field using specific wavelength of light. Additional cameras in the tractor allows for clear visibility in the field to ensure no workers are hurt during operation of the vehicle. The use case of different types of robots may vary, but the majority of them operate in proximity with humans or other machinery depending on the application. For example, an outdoor delivery robot uses cameras to help the teleoperator to navigate across streets and crosswalks. These cameras need to be able to distinguish between the colors on a traffic signal accurately. It is important that the camera feed is available with minimal latency for quick reaction time. Also, the cameras are used to ensure the robot does not collide with a pedestrian or other obstacle in its path during operation. In an indoor environment, the robots are used to carry material from one location to another while using the cameras to navigate autonomously. During navigation, the robots should be capable of planning its path and for obstacle avoidance. Hence, for these kind of applications, 3D depth information of the surroundings is required to do this effectively. To increase productivity, these robots sometimes operate continuously, which means it is important to predict downtime and plan maintenance activities. The health monitoring capabilities of GMSL2 interface allows the system to predict if there are any abnormalities in the data transmission and schedule preventive maintenance before the robots start to fail. In surveillance applications such as traffic monitoring, cameras are usually placed on the top of a high pole while the main compute is at the bottom of the pole for easy access. These cameras are used in some cases to regulate traffic signals and to avoid congestion. Because of the height, the cameras require labor intensive installation and maintenance on the field in case of problems. This is another example where the diagnostic information provided by the camera over the GMSL2 interface helps prevent costly repairs before system failure. Having understood the need for different imaging and optics requirements for different applications, we have a vast portfolio of off-the-shelf GMSL cameras ranging from 2 megapixel to 8 megapixel. We are partnered with all the major image sensor vendors such as Onsemi, Omnivision, and Sony. We test these sensors rigorously for performance and tune the camera settings to get the best performance out of them. We have two product lines for GMSL cameras. The cameras without an enclosure is called the Nilcam series, and the cameras with IP rated shock and vibration proof enclosures are called the Steadicam series. They support different imaging features such as high dynamic range, low light capability, global shutter, and so on. Depending upon the use case, we can help someone new to GMSL get started with these cameras to various different platforms by leveraging our partner ecosystem. We are partnered with almost all the major ARM compute providers such as NVIDIA, Qualcomm, Umbrella, NXP, and many more. We have readily available software drivers for our off-the-shelf GMSL cameras for many of these platforms. Depending upon the user system requirements, we can interface these cameras to off-the-shelf carrier boards or box PCs from any of our partners in this list. In fact, many of our camera drivers are already integrated and tested with these BSPs from the partners. This makes it easier for new users to just buy a compute box and the camera of their choice and start testing immediately without worrying about software driver integration. If you wish to learn more about our GMSL camera offering, you can go to our website or scan this code which takes you directly to the web page. In case you still have further queries, please feel free to reach out to us at camerasolutions@econsystems.com. Thank you all for the opportunity to speak about functional safety in GMSL cameras and for spending your valuable time to listen in.
Thank you, Dilip and Tom, for your insights on the role of GMSL2 cameras in autonomous systems. As you rightly mentioned, it is really valuable. We'll now move on to the Q&A segment. Please ask your questions about GMSL cameras and their impact on functional safety. Here we got the first question. Autonomous systems require different combinations of cameras to support different applications like DMS and surround view systems. The main SoC in the ADCU can also vary. How should these different cameras be integrated with the ADCU?
I can probably take this one. Like I mentioned, so different imaging requirements are needed for different applications, and we have off-the-shelf options for these type of commonly used use cases. And the biggest challenge with integrating these with different ADCUs is the software part of it, which is the drivers. So we have off-the-shelf V4L2 based drivers that can be easily integrated to any different platform. And in case you have a specific request, you can always reach out to us, and we'll be happy to help you integrate the cameras into the specific ADCU of your choice.
We got the second question here. How does the latency of GMSL2 interfaces compare to other camera interfaces used in autonomous systems?
I can take that one. Yeah, that's a good question. And so GMSL was really designed to be put right at the PHY interface. And these GMSL devices operate at microsecond latency, which has enabled automotive ADAS features to receive that data real time, quickly and accurately, and then actuate fast moving vehicles with people inside of it as safe as possible. So GMSL devices, my colleague likes to say, are simply an extension of the PHY over distance with no processing latency. So as soon as that line buffer in the deserializer fills up, we're sending that data right out to the processor.
Great, Tom. We have another question. Does the camera have a trigger function to start recordings due to the event? Example, voltage over the threshold. I would like to have two cameras sync accurately. This was the question.
Yeah, so I can take a stab at it. So yes, all GMSL cameras, we do have synchronization features to do the sensor fusion where you can synchronize multiple different cameras at different cable lengths and ensure that they're all synchronized as accurately as possible. That can be done. We have a variety of ways of doing that frame synchronization inside these GMSL chips with a variety of frame synchronization capabilities.
All right, Tom. So we got
Maybe
another
I
question.
can also add a little bit to that.
All right.
So yeah, some of the cameras that we already have off the shelf already have synchronization capability on it, even on the sensor level, and that is transmitted over GMSL link using the same cable. So you don't need an additional cable, and we test them even for stereo applications where two cameras need to be in sync with each other. These are already enabled for the majority of our cameras.
Okay. So we got another question. What safety features do you think are important for cameras in autonomous systems, and how do you make sure they are part of your designs?
I can probably take that one. So, in terms of safety features, like uh, Tom mentioned, so GMSL already allows a lot of diagnostic information to be transferred to the host. So that's something we already uh, provide as a feature in our cameras. So on top of that, we provide a health monitoring library that is used for seeing some of the diagnostic information to see if there is any issues with the camera link, if there is any issues with the sensor, if there is an issue in the cable. So this level of information can be gathered using the health monitoring library. But to be fully functional safety compliant, such as ISO certifications or other IEC certifications, it is also important to have the complete system have a security component to it. So there will usually be a safety MCU that looks into these data, these diagnostic data, and looks at the data real time and make sure that there is no error in the system. And if there is an error, it takes preventive mechanisms or other options to do that.
Great, Dilip. I think the next question is for Tom. How does GMSL compare against FPD Link?
Yeah, so
That's
GMSL and FPD Link are, they're both SerDes technologies that are widely used and adopted in a variety of applications. But GMSL is able to support the full MIPI CSI2 spec, and it enables up to 30 megapixel or 8 megapixel 30 FPS sensor resolutions with low latency, low bit error, and really these detailed error monitoring and diagnostics while being able to operate in these harsh environments. So all these devices are designed with that ASIL rating at a component level, and we also provide all the functional safety documentation with these devices. But another big aspect of this is we're trying to make large efforts to grow this GMSL ecosystem. For example, partnering with econ systems to really enable quicker time to market with the GMSL technology.
All right, Tom. So we got the next question. What is the maximum cable length and bandwidth supported on a GMSL?
I'll take that one. Very common question. So GMSL today operates up to GMSL2 operates up to 6 gigabits, and GMSL3 operates up to 12 gigabits on the link. Um, that is the fixed frequency at which the data will be sent. And the cable length all depends on the characteristics of that channel when you're going from the pin of the serializer to the pin of the deserializer. So GMSL on analog.com, we have the GMSL2 channel specification document, which details the insertion loss and return loss budgets that you can have for your system. And that translates directly into cable length. So if you have a very lossy cable, it'll be harder for us to receive the signal at the end of that cable. And with that, we provide some general suggestions on losses allowed for the cable, the connector, the boards. And with that, in typical, worst case automotive conditions, you may see the number 15 meters thrown around a lot. And that's really a more specific implementation with automotive grade temperatures, cabling, and connectors. But as we look into these other markets, we are seeing GMSL able to go further with lower loss cables, different temperature environments. So I hate saying it depends, but it really does depend on how you want to implement it into your system.
All right, Tom, we got another question for you. What is the maximum cable length possible with GMSL2 or GMSL3?
That sounds to be very similar.
Do you want to explain more about GMSL3?
Um, sure. Yeah. I mean, it's similar to the last one, but yeah. So GMSL3 also operates with a channel specification document that we'll be releasing later this year to enable you to calculate the overall maximum losses in your system and translate that back to cable length that you can run the application on.
And maybe to add some more context to some of the questions, we already have GMSL2 products available for customers to evaluate and test on different platforms. In case you're interested in GMSL3, it's soon to be released. We already have few samples available, which we are not yet promoting, but once we have everything ready, we'll be launching that to the market and people can just get started with testing it. I think that should be done towards the end of this year.
All right, Dilip. So here we have another question. Is there a common mechanism to trigger video streaming from camera to ECU? Or is it dependent on the ECU implementation that the camera streams data once connection is established or wait for a request from the ECU?
I can take that one. So the usual mechanism for triggering video streams is there will be a software driver that initializes the settings for the camera. So once the cameras are connected and the ECU boots up, this initiates a sequence for enabling the camera. And this will also start the streaming process where the camera resolution and the format is predetermined in the ECU itself, in the software drivers. This can obviously be modified depending upon the requirement. And in case you want to synchronize multiple cameras with a trigger mechanism, that will also be supported depending upon the camera sensor. So different sensors have different trigger requirements. So if you want to trigger the image and capture it, that will have a specific communication. But for standard video streaming, it should be much more simpler.
All right, Dilip. So we got some other questions as well. Do you need any special licenses for using a GMSL device?
No, so for our GMSL camera devices that we have released there, those are all standard parts, no special licenses required. Um, as we have other devices that deal with protected content, like in the display realm, which is another avenue where GMSL is used, there are some special licensing agreements, but with the cameras and everything that we've demonstrated here, there's no licenses required.
All right, Tom. We got another question. Do we need different serializer, deserializer hardware for different econ cameras?
I can take that. So for the majority of our cameras, we have compatible GMSL deserializers as well. So even for off-the-shelf cameras, we provide the deserializer hardware that can be easily plugged into any NVIDIA-based system for quick testing. But if you have a specific deserializer design that you made yourself, and you want to make sure that the cameras that we have are compatible with it, you can reach out to us and we'll be happy to help make sure that they work in parallel. So we use the common deserializer chipsets for GMSL2 that's available. So it should mostly be straightforward.
Okay, good. We got another question. Could you speak a little bit to the publicly available GMSL device and collateral availability? Do we need NDA for GMSL?
Yeah, so that's another great question I can touch on. So, GMSL for the longest time was required an NDA to get access to the information, just because there is a high demand for it, and a lot of the use cases really, we just the bandwidth wasn't there. But part of the initiative that ADI has to grow this technology is to enable anyone to use GMSL. And so all the parts that you see that are available on analog.com don't require an NDA. We're putting collateral out there. We're doing webinars like this. So on our website, you'll see data sheets, you'll see EV kit information, our channel specification, hardware design guide, some software drivers, adapter boards. We're really trying to make GMSL as easy and accessible for anyone to implement into their system. So that's, as Dilip was mentioning, GMSL3 will be coming out later this year. We really want to ensure that the customer experience with GMSL3 is good and there to provide all the material out of the gate. And so that's what we're working very diligently on, preparing that to make sure that it's as easy to use as possible.
All right, Tom. We can take one last question. GMSL cameras uses deserializer where CSI interfaces are used. In that case, normal I2C is needed or CSI interface CCCI, I2C itself we can configure for deserializer.
I can probably address this. Uh, so the I2C or the CCI interface depends on the host platform that you use. Uh, in this case, so we have camera drivers already available, and these drivers will configure the serializer as well as the deserializer depending upon the host platform. So we can, in case you're using a different design, we can provide you reference drivers that we have for some of the off-the-shelf available carrier boards, and using that you can modify it as per your needs. But it should be straightforward as long as you have enough details or the reference driver from us. I think there is one more common question that keeps jumping up. Uh, will we be sharing a slide deck? Maybe Anusha, you can answer that.
Yes, of course. If you couldn't make it to the entire webinar, please be rest assured that we'll be sharing the PPT and recording to all the registrants. So no worries about that. I think it's time to end the webinar. Thank you for all of us joining us today. We hope you found the session valuable. For further questions or information, feel free to reach out at camerasolutions@econsystems.com. Stay tuned to our social media for updates on oncoming webinars from Econ Systems. Thank you and have a great day.
Thank you very much.
Thank you.
Thank you.